Hello. In this lab, we are examining the motion of a star around a black hole. The lab generates the star's trajectory around the black hole using Glowscript, and the star's motion is analyzed because we want to know the net force acting on the star. We're operating on the assumption that the net force is equal to the black hole's gravitational force. Lastly, with this force, we find the mass of the black hole. Now onto the Glowscript code. The trajectory of the star is manipulated by my email address over here. The code proceeds to use my email to generate a random trajectory for the elliptical orbit, and with that the positions are found and used to calculate the velocity. Here's the gravitational constant, which will be used to calculate the mass of the black hole. The mass of the star is given as 2.03 times 10 to the 30 kilograms, and the delta t is in iterations, which are the length of a day. With the velocity calculated, so is the momentum. And the change in momentum over change in time equals the F net, or in other words, the rate of change in momentum, as stated in the momentum principle. Using the rate of change and value of initial momentum, we can find the value of its parallel and perpendicular components. Momentum is its magnitude times its unit vectors. So with some calculus, the formula for rate of change in momentum is found, revealing how to find the values of the components. With these formulas put into the code, the simulation will be able to depict the arrows pointing in the directions of the F-nets, the F-net parallel, and the F-net perpendicular. The mass of the black hole is found using the gravity equation, which is shown here. The equation, as you can see, can be manipulated to isolate the mass and calculate using the now known values of the mass of the star, the magnitude of the F-net vector, and the gravity constant, and the magnitude of the distance between the two masses. The code writes mag of star position for r because the position of the black hole is at the origin. And with all the coding done, now we can see the simulation. This represents the star moving around the black hole in its orbit. The pink arrow is the parallel components of the rate of change momentum, the blue being the perpendicular, and the orange being the F-net, which is the sum of the vectors. With that shown, here is some final analysis. Is there a difference between the rate of change momentum and its components and the net force in its components? The difference is only a matter of measurement. The two values are mathematically identical because the only force in the system is the gravitational force of the black hole, which is the F-net. However, when making measurements, it's impossible to find F-net using Newton's gravity equation because the mass in the black hole is initially unknown. Therefore, the mass of the star and its velocity data are used to calculate the rate of change in momentum to assume the value of F-net. The lab will then end with this hypothetical. What if a different black hole was placed in the same location of the original black hole? However, the motion of the star is the same and the only force acting on it is from the black hole, as it was before. If this were the case, the mass of the black hole would be identical to the mass of the previous one, because with the motion being the same, the F-net will be the same. Thus, the mass will be the same as before. And that's it. Thanks for watching.